Okay, so over here, these two pieces of the equation tell us where the two pieces meet. So at x equals 1, that's kind of like a borderline between the two pieces. All right? So now, f of x equals, that's telling us the same thing like y equals. And then we're going to start with the top function. And I don't know if they're always in order, but I always put them in order, where this is going to be the left piece. Because we'll always go left to right the same way we read. And I'm going to make a table. I'm not going to even think, oh, sorry, I didn't realize that moved. I'm not even going to make it too hard on myself and try to do transformations or try to worry about 2 is the slope, 3 is the y intercept. I'm not going to think about anything like that. I'm just going to make a table of values, x, and then when I plug it in, I'm going to plug it into 2x plus 3. But that x is less than or equal to 1 tells me the point that I'm actually going to plug in. I'm going to plug in 1, 0, negative 1, negative 2. I'm plugging in numbers that are less than or equal to 1. Okay, so I'm going to plug in 1. I'm going to get 2 plus 3, 5. 0 is going to be 3. Negative 1 will be 1. Negative 2 will be negative 1. And then I'm going to go plot those. There's kind of one important thing when you start plotting them. You need to look at this inequality sign. This one is less than or equal to. So the or equal to part means that it could be equal. So when I graph it at this x equals 1, it's going to be a closed dot. So at 1, x equals 1, 5, I'm going to have a closed dot. At 0, 3, negative 1, 1, 2, negative 1. All of those are on the line, and those are just the ones that I chose. So you may have chosen different numbers than me. What kind of graph is this going to make? It's linear, so a line. So I'll use my straight edge. And I'm only going to make the line for values that are less than or equal to 1. So I'm only going to graph the line to the left. Starting here at that closed dot, going to the left only. That is a piece of this function. Then we look at the other piece of the function, negative x plus 4. And these values are going to be that x is greater than 1. X is greater than 1 means it doesn't equal 1. But it does mean it equals 1.00000001, like anything greater. So I am going to include in my table 1. However, I know that it's not going to equal 1. And then things that are greater, 2, 3, 4, 5. I'm going to plug those into negative x plus 4. So you get negative 1 plus 4 is 3, negative 2 is 2, 1. And when I graph this, my very end point, this first point, is going to be an open circle because it cannot be equal to it, but it's going to be all the way up to it. So I'm going to start at 1, 3, but that's open. And then 2, 2, 3, 1. And it's a line, so I could continue my pattern or just use my straight edge, draw my line. And that's it. That's a piecewise function. So we just have different parts of a function held together, and it passes the vertical line test because what happens right here when x is 1? How many points do I have? Just one, the blue one, and then the red one's open. And then there, from there on, it's red. So to the left is blue, to the right is red. That's it. Okay, let's do another one. So now they're not lines. What's the first one?
Quadratic.
Quadratic, so parabola. And the second one? Square root. I like to do these in two different colors so that you can see my pieces. You are more than welcome to do that, or you don't have to do colors on your thing. Okay, so I'm going to pick numbers for the first one where x is less than 2. Is that going to be an open or closed dot? It'll be open, but I have to put 2 in my table. So that's kind of like the border. I'll just write the word open over here so I remember that it's going to be open when I graph it. So then I'll pick less than 2. So 1, 0, -1, -2, -2. However many you need. So 2 squared minus 4, 0. 1 squared minus 4, -3. -3. So 2, 0 is an open dot. 1, -3, closed. Oops, too high. I'm sorry, sometimes I gotta stand like right in front of it to draw a parabola. But I'll move. There we go. So it's everything where the domain, where the x values are less than 2. That goes to the left of the 2. If you need to draw in that line that's not really there at x equals 2 to help you, totally fine. It's just 2 different complete pieces here. And then I'll do my second piece, which is square root of x minus 1. That x is greater than or equal to 2. That tells me it's going to be a closed dot. So the first number I'm going to plug in is going to be 2. And then from there, what numbers should I plug in? 5. Why shouldn't I plug in 3? Because I don't want to take that square root and try to graph that. Exactly. I'm going to plug in numbers that make it easier. So if I plug in 5, that's my next one. Yeah, you want to think ahead and make it easier on yourself. And then what would the next one I should plug in be? It gives me a nice square root. Yeah. And then after that, I'm off the graph, so I can stop. So if I plug in 2, that's going to give me the square root of 2 minus 1, 1, 1. And then 2, and then 3. And then is this going to be an open or closed dot? Closed, we already wrote that down. So at 2, 1, closed dot, 5, 2, 10, 3. And then we have our square root. And that's it. That's a piecewise function. One more. So this one has 3 pieces. It's okay. And that's 3 pieces. What is that? Where would my kind of like breaks in the pieces be? X equals what? Look at my domain. Where are my x equals going to be? Put these numbers over here. -3 and +2. So if you like to have these separating, you don't have to, but if you like to have these lines separating, I'm going to have 1 piece over here, 1 piece in the middle, and 1 piece over here. And they're in order in the equation, in the function over here. So we'll do the first one. In blue, it is a line. And I have to start with -3, and then it says less than. This one's going to be open or closed? Open. It's be open. So I'll plug in -3, but what number should I plug in next? Let's make it easy on ourselves. -6. and then negative 9. Let's make it easier on ourselves. Let's plug in numbers we can easily divide by 3. So that'll give me 4, 3, 2. So at negative 3, 4, this says open. Then my middle function is absolute value, so I know it's going to be a V shape or, well, I don't know if it's going to be V shape. It just depends what part is showing. But I also know that less than equal to and less than equal to means both closed. So this says I need to go from negative 3 to positive 2. So I need to do negative 3, negative 2, negative 1, 0, 1, 2. That's the value of x plus 1. So 3 plus 1, 4. 2 plus 1, 3. 2. 1, 2. So at negative 3, 4, I'm going to have a closed dot. But there's an open dot sitting there. So I'm going to have a closed dot at the same place I have an open dot. What that does is it just connects the two pieces, where the other graphs we had like a break. It's still a function because only one of the graphs hits there. The other one's open. Negative 2. And then at my other end, it's also closed off. My third equation, x minus 2 squared. And I have to pick values starting at 2, but that's going to be an open value. And then 3, 4. So I can figure out what the graph looks like. So I'll plug in 2. I get 2 minus 2 squared is 0. 3 minus 2 is 1 squared, 1. 4 minus 2, 2 squared is 4. And then if I plug in 5, I get 9. So 2, 0 is open. 3, 1. 4, 2. 5, 9. Oh, I put the 9 in the wrong place. So that's a piecewise. That's it. Are we still scared? Okay, if you skip this kind of stuff, you don't spend time actually practicing it, you'll be like the kid last year that bombs this section, and it does not need to be difficult. Just gotta do pieces. All right. Turn it over. One last thing, never done before, probably, maybe, except for maybe you have. Have you done these before? So these are called step functions, or they're called the greatest integer function. You'll see why they're called step functions once we graph it. The greatest integer function says whatever's in those little brackets, you pick either if it's an integer, then it's its same number, or if it's not an integer, what's not an integer? Something that's not an integer. 1/3, so a fraction, or oh yeah, that's definitely not one. What else? I think somebody said it. So yeah, decimal. Yeah. So fractions, decimals, those are not integers. So the only answers that we'll have in the y column are integers. The x column, we can put in whatever we want inside here. It's just when you do this, you're only going to get out integers. So if I put in -1, what integer do I get out? 1. Integer is still -1. Okay, negative 1 is an integer, so negative 1 is what I would get out. Now, if I put in negative a half, it's going to be the integer that is less than or equal to negative a half. So if you're not an audio or like read words kind of person and you need to see it, here's 0, here's negative 1, here's negative 1 half. What integer is less than negative a half? Negative 1, because you go to the left. 1/10. What integer is less than or equal to 1/10? 0 is an integer. 0. It's like the stuff that you first put on the number line, you know. Those are the integers. 1.5. What is the greatest integer that is less than or equal to 1.5? 1. And then negative 2.1. Here's negative 2. Here's negative 3. Here's negative 2.1. Less than it is going to be negative 3. See, those negatives are kind of tricky. If you need to draw it, draw it. Now, we're going to graph this function. And you'll see, we'll get the parent function graph. And then if you remember transformations, you can use transformations. But let's see what the graph looks like first. So I'm definitely going to just pick some points to start. I don't think, oh, I do have the table. I was going to say I was looking for it, but it was over here. The table, I think I'm going to even use more points than you can see in that table. I'm going to start with 0. If I put in 0, what would I get out? 0 is an integer, I'd get out 0. If I put in 0.2, I would get out 0. If I put in 0.5, 0. If I put in 0.9, 0. What if I put in 1? That's going to be at 1 now. And if I put in 1.5, it's going to be 1. What if I put in 2? What if I put in 2.9? It's still 2. It's like going down. And if I put in 3, I get 3. So I've got some points that kind of show you what this looks like. I'm actually going to delete this graph. You guys have plenty of space because I zoomed in on your graph. I can't make it that big up here, so I'm just going to draw one. But like you guys will be able to fit it on your graph. I just can't up here. So I'm just zoomed in big time. Here's 1, here's 2, here's 3. Okay. So 0, 0 is definitely a point. So it's 0.20. So it's 0.50. So it's 0.90. Anything up to 1 is going to have 0 for the answer. But then at 1, the graph goes, oh, that answer is 1. So we don't leave this hanging. We put an open dot that shows that it goes all the way up to 1, and then it jumps up. So right here we have an open dot. And then past 1 at 1.5, it's going to be 1 still. Anything, 1 point anything is going to be 1 until I get to what number? 2. So at 2, I'm going to put an open dot and jump up to 2. So this will be a line right in between there. And then any 2 point anything pulls out and becomes 2 on the y. So 2 point anything until I get to 3 where it jumps up. Once you've done a few of them, just follow the pattern. You don't need to have a table with every single one of these in it. Once you've done a few of them, you can say, oh, okay, so it's going to look like that. And then there will be another one over here. It's going to be that. And it's going to follow that pattern. You can finish some more. Definitely put some negatives in there. Don't put some, negatives, positives, lefts, right, up, downs. And then think about what our domain could be. The domain is how far to the left and how far to the right. What x values am I allowed to plug into this little function machine? All real numbers. I can plug anything into it. Left to right, it covers every single point. But range is different. What numbers do I get out in the y column? All the integers. So you could say all integers You could make a list of integers. I'll show you different ways you could write it. Or you could have the symbol if you know the symbol for integers. So here's 3 different ways you could write it. Dot, 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 -3, -2, -1. I probably put too many in here. 1, 2, dot, dot, dot. So there you could like make a list. You probably don't even need the 3s. Maybe just -2 to 2. I don't know why I put 3. Or you could write integers, because that is a class of numbers. Or if you know the symbol, anybody know the symbol? If you know the symbol, you could write the symbol as well. It's like a fan. It looks like a Z, but or with an I. That was like tilted. I don't know if it's supposed to be a Z or an I, but that's what it looks like. The graph is what between each pair of consecutive integers. Then the graph jumps vertically at integer values. So in between the consecutive integers, what is the graph? And I don't want the answer a line. It's a different line, a different word that means this. Horizontal. Oh, not horizontal. It's a different line that means this. What kind of line is this? What kind of equation is this? What kind of function is this? Linear is a line. What? Yes, but I said not line. I wasn't looking for the word line. I was looking for is it constant. Okay, so really quick, let's sketch 2 others. How much time we got? How much time? Is it
7
55?
minutes.
Okay, it's 10. All right, so this one, if you understand parent functions and transformations, then this one would be a translate what? Up 1. So you could just take that first example we did and just go 1 with every single little, oh, do you see why it's called a step function? I was about to call them steps and I realized I didn't tell you. See, a step function? It looks like kind of like floating stairs. All right, so if you do not remember transformations and we haven't reviewed them yet, then just put numbers in, like put in 0 and then put 0 in and then you actually have to add 1. So 0 would be at 1. You put in 1, that would actually be at 2. That means at 0.2, that would make it 0 plus 1 is 1. 0.5 would be 1. 0.9 would be 1. So you can kind of like see where the stairs are if you're putting in numbers. So I have 0, 1, then it's constant until it jumps up to 1, 2.
Do you leave it in the stair step form?
Yep, this is exactly what the graph looks like. And there is a real life situation that models this, but I'm not going to say it right now if I don't have time, but I'll tell you tomorrow. Okay, and then look at the next one. If you remember transformations, you can try it. If not, just put points in. I'm about to change my page. I just know some people are still looking at it. Okay, so for this last one, if I pick 0 and I put that in, I get out 0, but then I have to multiply by 2 afterwards. So this would be still 0. If I put in like 0.5, I'm going to get out 0, but then I have to multiply it by 2, so it's still 0. So when I go to 1, I put that in, I get out 1, then I multiply by 2, I get 2. So if I put like 1.5, that's going to still be 2. It doesn't jump up until I plug in 2, but when I plug in 2, what do I get out? I get out 4. So my first stair is going to go from 0, 0 all the way to 1, 0 with an open dot at 1, 0. Then it's going to jump up to 1, 2. And it'll jump up to 2, 4. So then you can see that these stairs are just steeper. Because we had a vertical stretch, if you remember transformations. It's good to start hearing it now anyway. They're going to be wide, like the stretched vertically. Again, this is not difficult. Don't make it hard on yourself. Don't second guess yourself. Like, get into it and do it. I'm going to hand out your assignment for tomorrow, and I'm handing out the thing that you will be doing in class on Friday as well, which is a review. Handing it out early if you want to work on it early, if you're not going to be here on Friday. If you know you need help on other things and you want to get help sooner, I'm giving you your review early. And as soon as I talk, I already forgot how many I counted. Sorry. Yeah. This is the first, there's too many in this pile. The first pile is the homework that is due tomorrow. So we just, what do you guys do on there? The review? Yeah. How about count again? Okay. That's good for that, I think. And if you have an extra, I'll take it. You got an extra? Okay, next thing coming out is the review. And it says on it that it's a quiz review. I try to stay organized and label things. Try. William already has one. I won't do that.
So for review, are we getting homework then?
Yeah, but we will have class. No. We will have, I didn't rewrite that from last year. We will have class time tomorrow in class to do the review as well.